Do not confuse the three methods of proving similar with proving congruent, okay? It's not congruent sides we're looking for, proportional. So there's our first example. You guys have homework somewhere? Okay. So our first example here. We are given angle A congruent to angle D. Okay, let's mark those. And quite simply, they want us to prove ABE similar to triangle DBC. Well, are we given enough right now? Prove them similar? Is there enough in the given to prove them similar by one of these methods up here? No?
Angle.
Well, do we have that in the given?
No, never mind.
So we have to find something else. Like what else?
The vertical angle.
Yeah. So what are these? This is angle what? Angle what and angle what? B. There you go. Angle CBD. Congruent DBC. Vertical angles congruent, right? So now do we have enough to say the triangles are similar by angle? Okay, let's check like we did in the other ones, right? This A means congruent angles. Do we have that stated? There's one pair. The other A for the other pair, do we have that stated somewhere? Then we've got it. Okay, so the triangles are similar. Let's move down here. So this is kind of a messy thing. This is one where you might want to highlight the triangles they're trying to get after, right? Because it's a little fuzzy. So they give us an angle ADC and angle BEA are right angles. Well, what do you guys know about right angles? All right angles are what?
I would say perpendicular.
Well, for the purposes of what we're trying to get after.
Well, congruent.
Congruent, right? Okay. So we got a pair of congruent angles. Let's highlight these triangles maybe. I'll use a couple of different colors. So they want triangle ADC. ADC. Right? Maybe you can just trace out the ones they want. And then triangle AEB. So here's AEB. Like that. Okay? All right. So have we been given that a pair of angles are congruent? Yes or no? Have we? So I look in the given, it says two angles are congruent. The word congruent is somewhere near those angles. It's not given, is it? You got me? So you might have to state that. You definitely have to state that, right? So here's our given. You got right angles. Now, we have to state that they're congruent. Everybody got that? Okay, you got to have that in there. And why are these two angles congruent? All right angles are congruent. So we need another pair of angles, though, right? For angle. What would be the other pair? Do they share an angle, these two triangles?
Yeah.
Which angle?
Angle.
Angle A. Is it congruent to itself? What property tells us that?
Reflection.
Okay. Do we have enough to get triangles similar?
Yeah.
By what?
Angle.
Angle. Have we AA, right? Have we stated? So we didn't state it up here. We stated a pair congruent here for 1A. That pair congruent for the other A. We're good to go. Okay? So it's not completely different than the proofs we used to do. Okay? But now let's throw a little twist in here. So take a look at this given. We're given that these lines are parallel. They've marked them parallel for us, right? SR and TG. They want us to prove this thing. What is this thing? This is a what? It's a proportion. Well, where do we get proportions from here recently? From what? Of what? What kind? Similar, right? So if they want us to prove this proportion for what look to be corresponding sides, we should prove what first? The triangles are similar by one of those methods, right? So just one more step to this. So here's our given, right? They didn't really give us anything congruent in there, did they? Right? But since these lines are parallel, you know some things about angles, don't you? Right? So could we say that angle S here is congruent to angle G? Right? And using the other thing, the other transversal there, what about R and T? Now, why are these angle pairs congruent to one another? If you can't just say that, what do you have to say?
Parallel
If lines are parallel,
alternate.
all the interior angles congruent, right? So here we go. I wrap them into one statement because they're going to be the same reason, right? Now, you could have used these vertical angles here too, right? Would that be an extra statement of reason? You got the two here that you need. I will use that, right? So now we can say the triangles are similar, okay? Now that they're similar, you guys see that QR corresponds with QT, right? So they'll be in the same ratio as QS and QG. So here's the reason, right? We can now state what they want us to prove. Corresponding sides of similar triangles are proportional. Okay? Now you can't just write sides of similar triangles are proportional. What do you need?
Corresponding.
They got to be the corresponding. If you just write sides, it means any old pair of sides you pick, right? That's not necessarily true. You have to say corresponding sides of similar triangles are proportional. Everybody get that? There's one more step. We had to prove the triangle similar, and then take one more statement out here, right, to get what they wanted to prove. So, on the next page here. So here we are given that angle G is congruent to angle HIJ. So angle G congruent to HIJ. They want us to prove this. What the heck is this? That HI times HF equals HG plus HJ. What does that look like the result of doing here? It right? It looks like the result of cross multiplying. Cross multiplying a what? Two ratios, which is a proportion. Well, where do we get proportions from? Okay, so we're tracing it back, right? This looks like the result of cross multiplying, or the product of the means equaling the product of the extremes, right? Okay. So what do you think we have to do first? Get the triangles what? Similar. And then, like the last proof, get the what? Proportion. And then, when we cross multiply that, we should end up with this. Does that make sense? Okay? So how are we going to prove them similar? Looks like angle. They're not using the other ones a whole lot, but whatever. So here's our given. Now we need another pair of angles. Do they share an angle? They share angle H. It's congruent to itself, reflexive property. Triangles are now similar. Okay? Now that they're similar, we can set up this proportion right here with corresponding sides. And there is something missing from here. They didn't put this in. This is important. You better pencil this in. What did I put there? Corresponding sides, right? Okay? So HI, so what you want to do, think about this though. You could set the proportion up a couple different ways, right? Like big over small, whatever it is, right? But you want to set it up so that when you cross multiply, you end up with exactly what they have. Does that make sense? You might get them in a different arrangement that's correct, but you might not cross multiply to exactly that. So you want to be careful. So that we follow that, we get a triangle similar, then get the proportion, and then get this. And here's the reason, by the way. Go from the proportion to this. What's the reason? Okay, that's your justification for it. I mean, some kids like to write just cross multiplication here. I don't like that because it's not really a mathematical theorem. That's like a combination of operations, right? It's not really a thing in itself in math. But this is the thing in itself in math, right? The product of the means equals the product of the extremes. Okay? You okay with that one? All right. So you guys are going to try this example one here yourself, okay? So we'll take a minute, read that over, mark up your diagram, make your plan, okay? And prove those triangles similar. So he's got these two angles congruent, right?
And the second ones I got were angle E and angle ABC.
E and ABC, how many did it that way? You got, and then you got these two here, right? Did anybody do it a different way?
Well, I did.
What'd you do?
I did the first part of that, and then I did angle A is angle A.
So you went after, I think that's what I did too. You went after this one that you did too?
I did that one.
By reflexive property, they share. That's fine. So that's a couple different ways you could do that, right? And now, but either way, you still got the two angles you need, right? Okay, and that's all we needed. So we'll say that we'll use his. So step two, we're going to say angle ACB, or you could put a number in there if you want, congruent to angle F. Or you could have used B and E as well, right? Doesn't matter, because they're also corresponding angles. I don't know why I put 21 there. What's our reason for this statement?
If lines parallel over the interior angles are parallel.
If lines, what are they? They're careful, they're corresponding angles. Corresponding angles congruent. Okay? Be careful you identify the angle pairs, right? And Olivia and some others did angle A. Maybe some others did angle A, B, C, and E, right? But do angle A. So angle A congruent to angle A. Reflexive property, right? Does that give us enough to say the triangles are similar? Yeah, so let's state it. So for, just the way they have it, triangle A, B, C. Be careful here. Don't use a congruent sign accidentally, because that's incorrect, right? You'll get it wrong. Similar to triangle, and it's easy to do because you're used to writing the congruent sign all the time, right? Similar, that looks like an A. We don't want like a triangle. Triangle AEF. And our reason? Angle, AA. Any questions on that one? Okay. Let's look at this next one. You guys will work on that. This will be slightly different, right? So they got some numbers in here, so there's going to be a twist to it. You might need to see the result of what I do. Get there, but I think you'll have in your head maybe how to go about it. Okay? Take a look at it, mark things up. If you want us to prove angle A congruent to angle C, how do you think we're going to do it? Just generally. Well, more generally. Get the triangles what? Probably using what you said, right? Specifically. And then if two triangles are similar, what do you know about all their corresponding angles? Congruence, what they want, right? Okay? All right, take a minute. Struggle with this. I'll go ahead and maybe I'll call these. Most of you are probably pretty sure we got to get at these vertical angles, right? I'll just call them 1 and 2. Let's go ahead and get that in there. All right, so 2. Angle 1 congruent to angle 2. Vertical angles congruent. So does somebody want to show or tell me what their next step is? Olivia?
I need 2 divided by 4
Uh-huh.
and 4 divided by 5, and they both.
What are they equal?
0.8.
0.8 exactly, or was there more decimals? Okay. Well, what if you did it different? What if you did 5 over 4 equals 4 over 3.2? Could you do that? And when it comes to 1 point, what? 25? Either way, right? So it sounds like, so we got our angles, right? It looks like we're going to try to get side angle side, right? So if we can show these 2 pairs of sides, or these 2 and these 2, or no, wait. Yeah. Wait, which way does it go? But that way, right? Just think about this for a minute. Which pairs? What over what?
5 over 4 and 4 over 3.2.
Yep, okay, I'll buy that. Because, if it's a reflection, it's different. If it's a rotation, it's going to be a different setup, right? Okay, so 3, let's see, I'm going to write it like this. 5 over 4 equals 4 over 3.2. And then I'm going to put equals. When you put both of those in your calculator, what do you get? Well, I went the other way. 1.25. If you put the small on top, then you get 0.8, right? That'll work. That's fine. Use that, right? Yeah, okay, you do that, then I'd say then you'd have to put that in another statement down below, right? And then the reason would be product means equal product extremes, right? And so they're proportional. You can do that, but I think you need an extra statement. Okay? I'm just gonna do this. 1.25, right? So what do you think we should say? Are the ratios, did we show those two ratios are equal? And if those two ratios are equal, and we've just shown it right there, then what do we have?
Dilation by scale factor 1.5.
Okay, true. But what I'm getting at is the proportion, right? Which will give us the side angle side, right? So I might say something like this. I've shown these two ratios are equal, right? So now I might just say equal ratios means proportional, which is what we need, right? For side angle side. Are we catching that? So now we've shown in this statement that those two pairs of sides are proportional. And are these the included angles between them? Okay. Can we say the triangles are similar now? So what are we going to say? Triangle, let's see, ABE, similar to triangle what? CDE, right? Reason? This one is side angle side, right? But what do they want us to prove? Okay.
We could use alternate interior angles.
We don't have parallel lines though, right?
Wait, you can find out if all the interiors.
Those triangles are similar then. Which ones? Corresponding angles are? There you go, right? So now we can say we've got them similar, and you know when they're similar, the corresponding angle is congruent, right? Angle A congruent to angle C, okay? So we'll say if triangles similar, and I'm abbreviating, corresponding angles congruent. Okay? Oh, we did miss something, guys. I'm sorry, we did miss something. Okay, well, you math and pencil. Okay, so we had this proportion here, right? You might want to squeeze this in. What we really need, and I got so thinking ahead so much here. We really need to have the actual side segments named in that proportion. So does everyone see the given? You see the numbers in the given and what they're equal to?
Yeah.
So this 5 I can replace with what? You see what I mean? So now I need this statement in here. So let's squeeze it in here. I'm going to erase if you want to just, arrow it in or whatever. I apologize for that. So let me just get rid of this stuff here. I wonder if I can move it. See what I can do.
I have the arrow.
This is kind of, nobody,
I like that.
okay, let's squeeze this one in here. So let's replace these, right? So 5 would be AE over CE, right? Equals, and the other 4 was what? BE over DE. So what did we do to be able to justify this? What justifies going from these numbers to the actual segment names? What did we do? Things are equal, right? So what do we do? What? Substitution, right? So I'm just going to say substitution. And I might just include this, like to avoid any confusion when someone's reading it, right? With step one. I think so. What do we substitute with? We'll go back up to step 1 and take a look, right? You get that? So, yeah, I just missed that. So the numbers here aren't enough. Like, technically, you've got to get these segment names in there in the proportion, and we did that by substitution. Okay. All right, got the idea there? Yeah. Let's look at some Regents questions. Woo.
I love
Yes, well, many do.
Roll in favor.
All right, read this over, and kind of like what we did yesterday, before you start talking about maybe things are proportional or whatnot, you need to first determine something about the triangles, you know, in your head. Like what?
Do they say more?
That they're similar, right? You need some reason to believe they're similar before you can set up what you need to set up. Did we look at this one already? It's really familiar. Okay, anyway. So if we want CB, I think I'll just go in and put an X there. Any thoughts about how to get the length of CB? A proportion, cross multiply, right? But just as a technical matter, how do we know we can set up a proportion here? How do we know that? Huh? I mean, okay, so in all fairness, it's a multiple choice, you know, on the Regents, right? And, you know, you could probably just go through and do it. The work's not going to be checked, but I want you to think about this, right? Because a lot of these might not be a multiple choice. You might see a question like this in the written part, so let's think about it. How do we know we can set up a proportion here? We need to realize the triangles are what? Okay, so is it, well, over congruent even because it's 1 to 1, right? So how can we think about these being similar? What information do we have?
vertical angle D is 65, and then B, E, B, 20.
So right here, right, you're probably doing 180 minus 115 and getting what for this angle?
65.
65, right? Because they're a linear pair. This really, why you did this? I thought. Okay, anyway. All right.
There's one like it in 4.3.
I thought so. Okay.
It's not the same.
So those are congruent. And are these vertical? Did they just ask something different about it, didn't they? Yeah, okay.
The same.
Okay. So now that I thought that through, do we have similar triangles? So triangles,
Well, they were right.
what?
I was right.
Yeah, I was.
So now, as a technical matter, we can set up our proportion, and it's got to be at the corresponding sides, okay? So somebody give me their proportion here. You want to do big over small? I don't care. X over 4 equals, oh, that's a big over 15 over 6. There we go. So 6x equals, what's that, 60? Okay?
Trying to catch up.
X is 10.
I would not come to
So on the actual range, that you wouldn't need to go through and show they're similar, but I do want you to think about that. Because again, any one of these multiple choice, and it's why I don't treat my multiple choice like multiple choice. Because they may show one just like this, where it's like a 4-pointer or a 6-pointer or something like that, okay? All right, let's move along.
This time is more.
Ah, we got a little proof here.
Oh.
It's a simple one, don't worry. Read it over, mark it up. I think you guys have the tools to do this now. They want us to prove the triangle similar. They're not even getting after the angles in it, right? Just prove the triangle similar. Let's see, we got parallel here. Whoops a daisy. Parallel. Somebody want to tell me about how they're getting these triangles similar?
Vertical angles.
Okay. What's another way?
You know, like parallel.
Okay, so you got no. Which ones would they be? Think about it. Make sure you get that right. It'd be alternate interior, right? I'm going to use. I can get 2 pairs like that. For that reason, can I? Yeah. Then I don't have to do the extra statement of reason for the vertical angles, right? So we got angle G congruent to angle T, and I to M or N. Are the triangles similar now? Yeah. So let's do this thing here. Reasons. Get your given in there. Yeah, not much room. So 1, GI parallel NT. You can abbreviate stuff. Parallel to NT and IN intersects GT at A. IN. Say again?
We don't have to do it.
N to N? Is that what you said?
But if we put angle I instead of TIA.
No,
Yeah, you can, right, because there's no, right, exactly right. You don't need to use a 3-letter for any of those. Well, if you were going after the vertical angles, you either want to number them or use 3 letters, right?
Can I number all of my angles?
You can, but it's not necessary here.
I mean,
Yeah. I would just number the ones you're going to use and don't feel like using 3 letters for, right? So IN, what they got, intersects GT at A. Enter GT at A, given. So let's get the angles we found. We can now say angle I, let's see, G to T, angle G, congruent to angle T, and the other pair, angle I, congruent to angle T. What's our reason?
Blank parallel.
What did I get? What did I said, wait, G to T, I to N, thank you. I to N, what's that reason? If lines parallel, alt, int, angles, congruent. That gives us enough to say now the triangles are similar, right? So GIA, so 3, triangle GIA, similar to triangle TNA, angle. Huh?
you really did not give us much room.
Yeah, well, that's my fault. I copy and paste them and throw them in there and scrunch it up. Okay, so the next one, a little bit more complex, but not too bad. Take a look at it, mark things up, make a plan. You might want to highlight the triangles you need to get at, okay? Yes.
I think you just
Go ahead and mark this up, I guess. So it's a parallelogram. These guys are parallel. These guys are. Let's make sure we know what triangles we're getting at. So DEF and B. Oh, I guess they're the only 2 pairs, right? DGF. Looks like another angle one, right?
Yeah.
So what do we need to say here, guys? I'm just going to go ahead, let me get the given in and we can talk about the rest of it. So given is A, B, C, D, E, F, G, E, F, G, and tag them DFB. So thoughts, guys?
there's a vertical.
Yeah.
Vertical.
I got those, but I think we got enough with some
Angle B.
parallel stuff, right?
D, angle.
So let's maybe want to number these, right? So maybe call this one 1 and 2, and this could be 3 and 4. I don't feel like using 3 letters right now. But can we go ahead and say those angle pairs are congruent right now? We can. Why?
Opposite lines.
Oh, are they parallel?
Oh, we have to say.
Ah, you gotta state that first, don't you? Right? If you don't state that, that's a major error.
Major element, right? Can we do it on the same first? Like,
You do what?
angle 1, like,
Well, we have to state parallel first. Now, which pair of sides do we need to state parallel?
oh, all of them.
D, A, and C.
Okay, now let me just, I think I mentioned this before. Sometimes it's, you're not thinking right, which pair of sides do I need parallel to get the correct orthogonal interior angles. just state both pairs of sides parallel. And then you're covered, right? You'll never lose points for putting too much information down, right? So let's just say that DC parallel to AB, DC parallel to AB, and let's get the other pair in there just to be safe. And then AD parallel to BC. Okay? Jeff, this is definition, right? Because it's a parallelogram, right? So definition of parallelogram. Or if you want, you can say parallelograms that both are sides parallel. But this is short, okay? Well, what's that give us now? Now can we say these congruencies here?
Yeah.
Yeah, now we can, right? So what's our next statement?
Angle 1.
Congruent to angle 2, and for the same reason, what?
Angle 3 is congruent to angle 4.
Okay, easy enough. And 3. Now, if lines parallel, these are alternate interior angles being congruent. Right? That's important. You've got to have, they didn't state the lines are parallel in the given, okay? Because this is a condition, if lines are parallel. Well, are they? No one said it, right? So you got to say it. Well, what now? We got enough? Do we have enough to prove them similar?
Yeah.
This is angle, angle, isn't it? Angle, angle, right there, 4. So triangle DEF, similar, don't write congruent sign here. Triangle BGF. Or angle, angle. Huh? Not too crazy. I mean, you got some sense of how proofs go from before. We're just now changing it from congruent triangles to similar, right? Okay? Anybody have any questions on it? Right? So if the triangles are similar, you know that corresponding sides are what? Proportional. Right? If triangles are similar, corresponding angles are congruent, right? Okay? So like if they want you to get an angle pair congruent, you need to prove the triangle similar, right? Okay? All right, so the problem set, day 1 and day 2, you'll do